Airports. Every day, 8 million people use them to take to the skies. But how do these intricately designed mini-cities really work? To find out, we've subjected Frankfurt's International Airport to X-ray analysis to expose its inner workings. For the first time ever, using state-of-the-art camera technology and computer imagery, we'll see the engineering inside the planes, the machinery,
expect Alpha 28,
and the people. What you experience as a passenger is just the tip of the iceberg. This time, we reveal what makes an airport perhaps the most highly controlled environment on Earth. See pilots take on the ultimate test of control, landing a 390-ton super jumbo.
30, 20.
How precision systems load 100,000 bags a day.
Every piece of baggage that goes through our system belongs to somebody.
And how the airport even manages its ecosystem to prevent a disaster.
Mayday, mayday, mayday.
These are the masters of Frankfurt International. This is how they keep this mega airport under control. (7:15 a.m.) Flight LH761 from New Delhi is 37 kilometers east of Frankfurt and 30 minutes from touchdown.
Don't these clouds look fantastic? 761 direct to Ithaca. It's just beautiful. Pink clouds.
In the cockpit of this Airbus A380 are pilot Captain Joachim Schwarzenberg and his co-pilot Tobias Schnapp.
Frankfurt reports a dry runway with easterly wind conditions for runway 07.
Statistically, this next half hour is the riskiest part of their journey. The difference between a landing and a crash is control. "20 minutes to touchdown. Speed, 460 kilometers an hour.
Lufthansa 761 descent to level 120 to cross AP pilot level.
Altitude, 3,650 meters. Cabin crew take their seats for landing. Air traffic control tell the cockpit to reduce speed.
Lufthansa 761, speedback 230, descent level 110.
Lufthansa 761.
The controllers coordinate the speeds of all approaching aircraft to get them in line for landing.
So right now we got an instruction to reduce our speed to 230 knots, to getting slower, to get in the perfect separation to other aircraft. Getting speed, all blue, flight level 110.
By reducing the thrust from the engines, co-pilot Tobias drops his speed to 425 kilometers an hour. But at this lower speed, controlling altitude becomes a challenge. The aircraft's lift comes from air moving over the wing at high speed. As it slows down, the lift is reduced. If nothing else changes, the plane will lose altitude, falling at over 4 kilometers a minute. So 8 minutes before landing, the pilots actually make the wings bigger.
And now we are extending our flaps. We're getting lower than 200 knots and we extend the first time the flaps.
At the touch of a lever in the cockpit, slats emerge from the front of the wing and flaps from the back. The surface area increases by 15%. Air flows over the larger, more curved wings, generating more lift, and the plane stays in the air. "6 minutes to touchdown, 1,200 meters.
You can see the trail of another aircraft. That means we are just right above the clouds. Wow, riding on top of the clouds.
Captain Joe begins the next phase of landing. He must control his position during descent. He needs to land within a 100-meter touchdown zone on the runway, so he'll have enough room to bring the aircraft to a halt. But as the plane plunges into the clouds, he's now flying blind. At Frankfurt, over 7,000 landings every year occur with an impaired view of the runway. So pilots rely on the airport's equivalent of a lighthouse to guide them down. It's a transmitter that projects a tunnel of radar signals into the sky, called a glide slope. If a plane stays within this zone, it will touch down at the perfect point. It's crucial that no other electronic signals interfere with this system, which is why, in the cabin, your phone must be in airplane mode. Captain Joe checks his instruments to ensure he is within the glide slope.
We are on track for the extended center line, and we are just about to approach our perfect glide slope into runway 07 right.
Glide slope star?
Yeah.
4 minutes to touchdown. On the glide slope, Captain Joe's next move is to deploy the landing gear. The timing is critical.
Lowering the landing gear will increase the drag of my aircraft. So I'm doing this as late as possible, but as early as necessary.
Get up.
2,500.
Checked.
With the simple pull of a lever, a hydraulic mechanism pushes the 22 wheels into place. Each tire weighs 115 kilos and costs €4,500. Springs inside a cylinder brace the wheels into position. Without this, the gear could collapse on landing. 2 minutes to touchdown.
1,000.
Checked.
Checked.
So let's test this. Manual thrust.
At 1,000 feet, co-pilot Tobias disables the autopilot.
Manual flight.
For the first time since takeoff, the pilots are flying the plane purely on manual.
Cat 1.
They're sitting 7 meters above and 36 meters in front of the first rubber that will hit the runway. So a radar scanner constantly warns them of their true altitude.
400.
The point of no return is 200 feet. If Captain Joe can't see the runway lights then,
300.
he must abort the landing.
200. Minimum.
Continue.
Brain scans of pilots flying simulators reveal that during these final stages of landing, one particular area of the brain lights up. The bilateral caudate nucleus, a structure responsible for finely controlled eye movement and fast decision-making. During a tricky landing, this area goes into overdrive. Rarely more so than when in a crosswind. As wind buffets the plane, the pilot's brain must fight to maintain control of up to 390 tons of aircraft. Using the rudder pedals and stick, the pilot makes minute adjustments, their bilateral caudate nucleus coordinating all these movements. 20 seconds to touchdown for flight LH761. Fortunately, there are no crosswinds for the pilot's brains to battle. 30 feet above the runway, co-pilot Tobias performs the most delicate maneuver of the entire 7-hour flight,
30.
the flare.
Retard.
With a gentle pullback on the stick, he's aiming to slow the descent and make a smooth landing. Too much pull, and he'll generate too much lift, and the aircraft won't land. Too little, and the plane will slam into the concrete. Finding the perfect balance is the final test of the pilot's control.
For each landing, it's lots of feeling you need, how and when to start your flare. But if you summarize it, either you are too late, too early, or you are exactly right.
40. 30. 20. Retard.
Tobias cuts the engine thrust. And at 240 kilometers an hour, the giant aircraft inches down. Slowing this to under 1/30th of its normal speed. We can see the huge rubber wheels smoke as they accelerate from a standstill to over 900 revolutions a minute. It's a safe touchdown. But the plane is still hurtling down the runway. With the momentum, of 350 charging bull elephants. To bring the plane to a stop, an automatic system kicks in. Inside the wheel assemblies, the brake arms clamp onto the brake pads. Using the same anti-skid technology as your car, these brakes pulse to prevent lockup and skidding. Our thermal imaging cameras show how the wheels of an airliner immediately heat up to 400 degrees on touchdown. Fortunately, the brake pads, made from a carbon fiber composite, are designed to handle temperatures of over 900 degrees. But wheel brakes alone cannot stop this huge machine. So at precisely the same moment, the A380 deploys another automated system. Hydraulic rams inside the wings force 16 huge panels upwards. These spoilers create extra drag, slowing the plane and pushing its weight down onto the runway. In just 36 seconds, the A380 has slowed from 240 kilometers an hour to just 30. Flight LH761 is safely on the ground. And thanks to the pilot's control, you barely felt a thing.
Gentlemen, that was it.
Within minutes, passengers disembark, bags are offloaded, and the next flight's cases are placed aboard. But with 100,000 pieces of luggage passing through the airport every day, how do they make sure that every bag makes it to the right plane at the right time? 6 p.m. at Frankfurt Airport. In Terminal 1, Zone B, another passenger arrives to check in. You know the drill. But what happens to your bag once you've handed it over? Every day, passengers trust the airport with more than 100,000 pieces of baggage. Each case is precious, personal. You certainly don't want to arrive on holiday with someone else's underwear.
Every piece of baggage that goes through our system belongs to somebody. We try to think, what if that was my bag?
The airport aims to get every bag onto the right plane within 45 minutes of check-in. How do they do it? We've sent cameras deep into the heart of a vast underground maze. Their journey reveals that beneath the terminal's main floor is a network of 80 kilometers of tracks, tunnels, and loading bays. It's an engineering marvel, and the airport has pinpoint control of every millimeter of it. That's how 98.7% of the bags get on the right flight at the right time. The first thing the baggage handlers need is information. They find it in a remarkable piece of technology, the humble baggage tag. Hidden within the ink is a wealth of data. Alongside your name and destination is a 10-digit barcode, which includes the 3-digit code for your airline, a 6-digit serial number unique to your bag, and a single number that can be used to attach a special message, such as high priority. Tag attached, your bag disappears into the bowels of the airport, where it joins a giant hidden railway run by 23,000 motors on over 100,000 wheels, moving up to 20,000 bags at 9 kilometers an hour, day and night. All beneath your very feet. It's the ultimate train set. And Thomas Strunz gets to play with it every day.
Das hat noch ein Flair vom Flughafen. Es ist einfach hochinteressant. Man hat Mechanik, man hat Elektrik, man hat Steuerungstechnik und eigentlich ist hier alles das vertreten, ja, was die Technik zu bieten hat. Und das ist wirklich toll.
But with such a huge and complex system, how do handlers track the location of every single bag? The secret is a simple plastic tray, held in place by a metal chassis that stops the tray from flying off the rails at high speed. On the side of each tray and each chassis is a unique scannable code. The airport's computer system pairs these codes with the code on your baggage tag. So if it knows where the tray is, it knows where your bag is too. Within seconds of entering the system, your bag reaches one of the 1,500 junctions where the track splits. Ahead of every junction is a scanner.
Also die Lesestelle, die liest im Prinzip den Behälter dort unten. Und dadurch, dass er einzigartig ist, weiß die Anlage genau, wo er hin soll. Entweder nach rechts oder nach links. Und so wird er bis zum Ziel gesteuert.
An instruction from the central computer switches the points to send the tray along its pre-programmed route. If your bag is due for departure within 2 hours, it's routed directly to the gate. But any bags with a longer wait are sent to a vast holding area, where they circulate until the computer calls them to their gate. Keeping the bags moving past the scanners stops them from getting lost. But what if a component breaks on the railway? That's when Rod Clergy swoops into action.
We try to put ourselves in the position of the passenger. It's when you take it personally is when it counts.
Rod and his colleagues monitor every bag on the railway from inside the central baggage control room. Here they have an ingenious system, which means that even if there's a breakdown, most of the bags for a flight will still make it to the plane. And it involves letting go of a little control. The system is deliberately chaotic. The central computer sends bags for the same flight along randomly generated and slightly different paths. That way, if a section of track breaks down, only a few bags get held up. Meanwhile, Rod can get to work fixing the breakage.
When we look in our computer screen of the graphics of the system, I get a picture of exactly where the malfunction is and the name of the motor. So when I send the technician, I send him exactly to the spot.
Your bag finally reaches the gate. It's already been on a 10-kilometer adventure and has been screened for explosives. But there's still one final, vital security check. One set up after a terrible tragedy. In 1988, a Pan Am jumbo jet was blown up over the Scottish town of Lockerbie in a terrorist attack that claimed 270 lives. The bomb had been hidden in a suitcase, and one of the airports the bag passed through was Frankfurt. But no passenger had traveled with it. Today, planes can no longer take off with unaccompanied baggage in their hold. It's up to baggage handling team leader Alexander Forster to enforce this rule. As you arrive at your departure gate, your boarding pass is scanned. The central computer links this to your bag and tells Alexander you've made it onto the plane.
Und momentan hat dieses Gepäckstück noch einen grünen Status. Wenn der Passagier jetzt nicht sich am Gate befinden würde, würde es hier einen Rotstatus geben und das Gepäckstück müsste ausgeladen werden.
If a passenger doesn't board the plane, the baggage team has to locate the bag and remove it fast. Fortunately, all the passengers for this flight made it to the plane on time. But there's one frequent flyer who never uses this high-tech baggage system. He travels with hand luggage only, and he likes to fly in style, without paying the airline a penny.
I don't remember the last time I've flown economy.
7:45 a.m. at Frankfurt Airport. And on his way to gate C14, frequent flyer Ben Schlappig is transferring between flights.
In the past few months, I've taken a shower in the sky on Emirates. I've been driven to a plane in a Porsche on Lufthansa. I've had a double bed to myself on Singapore Airlines.
Ben's no millionaire, but he flies like one. So how does he do it? The answer lies in his total control of perhaps the most complicated system in aviation, air miles.
I do have some air miles, yes.
I collect air miles mostly of Airfloat. It's a Russian company. It's got like a gold status in a couple of them.
Air miles are rewards programs run by airlines. When you take a flight, you earn air miles, which can be redeemed later to buy another flight. Most passengers know this much, but not much more.
I haven't been able to collect enough points on one given airline.
But I haven't yet earned enough to be able to put it back to a plane. I do not collect air miles, so I don't have any.
But Ben has total control of the air miles system, and he uses it to fly wherever he wants, whenever he wants.
Most people don't understand how miles work. Of course, if you actually know how to play the game or how to game the system, there's ways to get incredible value of the miles, kind of more than the airlines ever intended.
Ben has 5 million air miles, enough to fly to the moon and back 10 times. He's a very frequent flyer, thanks to his job as a travel writer. But he multiplies his miles into millions using a cunning method called mileage running.
Mileage running is when you fly for the sole purpose of accumulating miles. So you get on a plane, and the only reason you're doing so is to earn miles. It's something that a lot of people do, and it's a bit of a crazy hobby, I guess, but it's a lot of fun.
Mileage running works by earning miles on cheap flights and spending them on expensive ones. Over a week, Ben might take 30 discounted flights. They only cost him 700 euros, and he'll earn 62,500 air miles. He then uses those miles to buy a first-class ticket to Japan, which would have cost him 12,000 euros. And flying isn't his only way of running up the miles. Through Ben's eyes, the airport is teeming with hidden air mile grabbing opportunities.
I have about 40 different credit cards, and I use them to maximize the various bonuses that credit card companies have. So for each of these cards, I earned about 50 to 100,000 miles just for applying for them. For example, earlier in the year, American Airlines and Citi offered 100,000 miles as a sign-up bonus on their credit card. And you could actually earn the bonus multiple times. So you could apply for that card every 2 months. So I picked up 5 of those credit cards.
What you see as a stack of credit cards, Ben sees as a luxury trip around the world.
This is about 5 million miles worth of cards, probably, when you factor in everything I've earned from them. So that's why I need 3 wallets to keep track of all of them.
3 wallets contain all his money, while 2 carry-on bags contain all his possessions.
I'm, I guess, voluntarily homeless. I live in hotels full-time. So I literally live out of a carry-on, and here's what's in mine. So the first thing is I roll everything. It saves so much room, and it keeps it from wrinkling. The other thing is I put all my socks inside of shoes. That way they keep the form and it saves space. And I also put my shoes inside a shower cap. That way they don't get your clothes dirty. You know, so living out of a suitcase is a bit bonkers, but frankly, it's helped me realize what's important in life and that you can actually live off of very few material things, and that's a good thing.
Thanks to his mastery of the system, Ben and his carry-on bags head to the gate without having paid a penny to the airline. 4,000 passengers an hour surge through this departure concourse. Watching the action is passenger flow expert Dr. Michael Schultz. And amongst the chaos, he sees order.
When people look at the crowd they see individuals with sometimes unpredictable behavior, I can see patterns.
To spot patterns, he doesn't watch individual passengers. Michael watches the crowd.
The single passenger is not so important for the whole airport. You need the flow of the whole system. If you want to improve the system. You do not improve one single movement, you improve the whole movement over the day.
Experts like Michael are subtly steering the movement of all these people. Precision scheduling means that a plane can't wait for passengers who get lost in the terminal or stuck in a security line. So the airport must get you to your gate in time for boarding. They do it using Michael's patterns. Pattern number 1. Different passengers move in different ways. This graphic shows how. The gold dot represents a business traveler. She walks quickly, taking the fastest, most direct route to the gate. The blue dot is a tourist. He tends to arrive 2 to 3 hours before his flight and traces a slower, meandering path through the terminal.
People have their own interests, their own motivation, their own intention.
Visualizing Michael's data, we can reveal other surprising hidden rules about how we walk. We can see that men travel 10% faster than women. A party of 4 moves slower than a party of 2. And groups of passengers often walk in a V formation so they can talk to one another. They actually act as a rolling roadblock to passengers coming the other way. Culture clash can also disturb flow. When encountering someone coming the other way, Europeans tend to step to the right to avoid one another. Passengers from Asia tend to step to the left. When a European meets an Asian, you've got an instant traffic jam. Now that he knows the passenger flow patterns, Michael can start controlling them.
We want to optimize our infrastructure just to ensure that people can go really fast from the entrance of the terminal up to the gate or the other way around.
Take the travelators. They do much more than just give tired legs a rest. Instead, they use the pattern that different passengers want to travel at different speeds. The travelators create a one-way system with 3 distinct flow streams in each direction. One consisting of passengers opting not to use them, a second slow lane of people standing on board the travelator, and a third fast lane for those in a hurry. By controlling the passenger flow patterns, travelators turn a single-lane, single-speed corridor into a 3-lane highway. But there's no point speeding up passengers if they don't know where they're going.
You're just trying to find your way around, you're confused, you're excited, but you don't know what you're doing at the same time.
Long corridors of nothing, and you're not sure if you're going in the right direction.
On a level 1 to 10, when 10 is chaos, I think it's minimum 7.
Here to prevent any chaos is Gregor Kallat. He's responsible for the airport's 7,000 signs. Gregor's signs are designed using a simple philosophy. Less is more.
We are reducing information, reducing. This sign is like a sentence. Gate B41 straight on.
The ultimate in simple signage is the pictogram, a graphic symbol designed to work in any language.
If you want to take a shower, it's dropping water down. I can take a shower there, and you do not have to understand English or German writings.
Of course, it helps if everyone understands your symbols in the same way. Some passengers confuse Frankfurt Airport's pictogram for the lifts with the one for the toilets.
It's not funny when they don't find the toilet, for example, for sure. It's a big problem.
Lift, toilet. Toilet, lift. Try to remember the difference. But even the perfect sign can't stop queues from forming. And when they do, it's Salvatore Kuntu's job to get rid of them.
From this chair, I can see both terminals, Terminal 1 and Terminal 2, and all security checkpoints, all border controls, arrivals and departure.
It's 9 a.m. And Salvatore is using hundreds of CCTV cameras to monitor every inch of the terminals. He must detect any congestion quickly. If he doesn't clear it fast, passengers could miss their flights. Salvatore spots a queue forming at a checkpoint in Terminal 1. From his desk, he changes the message on the signs to direct passengers to a different checkpoint. It takes less than 10 minutes for the sign to work its magic.
Now, as you can see, the line is no longer there, and we solved the problem and the congestion.
Thanks to Salvatore and his team, 75,000 passengers filter smoothly through the terminal onto 600 different flights. But before these planes can take off, the airport must control the skies.
Mayday, mayday, mayday.
In the last 16 hours, 150,000 passengers have flown through Frankfurt Airport's terminals. But every day, this human tidal wave leaves something in its wake. 17 tons of rubbish. In Terminal 1's service area, Lars Jorgens is briefing his team.
Heute müssen wir richtig Gas geben. 630.000 Quadratmeter Bodenfläche warten auf uns.
Lars commands an army of 660 cleaners, tasked with keeping the entire airport spotless. It's a monumental job. But it's more than just litter he and his team must remove. A dusting of powder and ultraviolet light reveal the handprints and smudges left on tables, guardrails, and chairs. The average human hand carries over 100 species of bacteria. As an international crossroads, this is a potential gateway for the spread of disease. Controlling the cleanliness of the airport is not just about looking good. It's a war against global epidemics.
Natürlich, theoretisch betrachtet, wäre das eine Riesenkatastrophe. Reinigung ist nicht nur ein Thema der Hygiene und der Optik, sondern auch der Trittsicherheit.
It's 10:25 p.m. and as the last flight departs, General Lars gets to work. His elite troops have just 7 hours to get this place spick and span. A squadron of 8 floor polishers scrambles into action. The turbocharged Tennant T-15 rider scrubbers scour 630,000 square meters of paving. A platoon of electric cleaning trolleys with a breakneck top speed of 10 kilometers an hour ensure passenger areas are cleared in time. And a fleet of bin collectors remove 17 tons of litter, recycling an astonishing 84% of it. "6 a.m. Lars's cleaning team have completed their Herculean task. The terminal environment is back under control. But out on the airfield, Jürgen Ebert is just starting his shift. It's his job to control this far wilder environment.
Hast du das gesehen da drüben? Da haben wir auf dem Masten da.
Jürgen must manage the airport's flora and fauna. And his biggest headache, birds.
We have about 2 or 3 bird strikes per 10,000 movements. It's about 100 or 200 bird strikes per year.
A bird colliding with a plane's engine usually comes off worst from the encounter. But occasionally, these collisions can cause serious mechanical damage, putting human lives in danger. In 2007, This passenger jet suffered an engine failure after hitting a bird on takeoff.
Mayday, 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 engine failure.
It was forced to make an emergency landing.
To give you an idea what can happen with a bird strike, I can show you fan blade from an airplane engine. It rotates in the engine, and here a bird struck the engine, and this is completely broken out here. And this is solid metal, as you can see. This gives you an idea how severe an impact can be.
In 2009, US Airways Flight 1549 hit a flock of geese 2 minutes after takeoff from New York, disabling both engines. Flying without power for 4 minutes, the plane made a miraculous water landing on the Hudson River.
For a second, I just thought that I was going to die right there.
It was only because the immensely skilled pilot managed to control the water landing that everyone survived. So how does Jürgen control these birds? His first tactic is to stop them from feeling at home.
Animals, birds usually want to feed, they want to rest, and they want to breed. So we avoid any food for birds, we avoid nesting places, and make the habitat as unfavorable as possible.
Sources of food like berry trees have been removed, and the grass is allowed to grow long, so hawks and falcons can't see mice or other prey. There is no open water in the airport's 2,000 hectares, and spikes on lights and signs make them unwelcome landing sites. And for any birds that do decide to stay, Jürgen has another trick up his sleeve.
Sometimes we use pyrotechnics to scare the birds away. The problem is when you use this too often, birds get accustomed, and that's why it's one of the last measurements that we do.
So far, so straightforward. But Jürgen faces another, more complex threat. Just 1 kilometer from the airfield is the River Main. Migrating birds use this river as a highway for navigation. The airport needs a way of spotting these flocks in advance. Inventor Holger Vogel came up with a solution. Mivotherm.
The system detects a crossing flock of birds here at this point and can predict then their arrival, very accurate.
3 towers are positioned alongside the River Main, each with 2 stereo thermal cameras. As soon as the cameras detect a large bird or a flock, they can automatically determine its size, altitude, and heading. The system then calculates whether these birds could pose a danger to landing aircraft.
We have an early warning in advance of about 2 to 7 minutes.
If a bird strike looks likely, a warning is forwarded to pilots,
Lufthansa 711, wind 170 degrees 5 knots, runway 25.
giving them time to react.
This is the only system existing in the whole world that can do a detection and prediction of birds like this.
Holger's unique system takes care of the migrating geese. But on the airfield, Jürgen still has another type of bird to contend with.
The most dangerous birds for airplanes are predator birds because they circle in the sky and look for prey on the ground.
To get rid of these birds, Jürgen plans to re-engineer the whole ecosystem, using some very unusual allies.
We like to have some foxes out on the airport because the fox feed on mice.
The theory is that the predatory birds are hunting mice, and so are the foxes. If there are more foxes, there will be fewer mice. Fewer mice will attract fewer birds, which means fewer bird strikes on planes. That's perfect, controlled engineering.
By beginning of next year, we want to build artificial fox dens so that we can take care about the population of the foxes.
5 man-made fox dens will be strategically placed around the airport. 10 foxes will be working round the clock on the wildlife management team. Ecosystem tamed, terminals mastered. But there's one more environment that modern aviation also controls: the space inside a cruising airliner. Sitting in the economy cabin may not feel like the height of modern technology, but the fact that you're sitting here at all is a wonder of science. You're 12 kilometers up, hurtling along at 900 kilometers an hour in a metal tube. On the other side of the plane's millimeter-thick aluminium skin lies a death zone, where the atmosphere is too cold and too oxygen-starved for human beings to breathe. And yet, you're most likely bored. This is only possible because everything from the air you breathe to the seat you sit in is the product of years of scientific research. Here, at the Recaro Seat Factory, they design, test, and build seats for Lufthansa's fleet.
When designing an airline seat, first of all, comfort is extremely important. You can imagine the passengers stay for a long time in the seat. They eat, they work, they relax, they even sleep in the seat.
In the 1950s, aeroplane seats were built to withstand up to 9 Gs of force in a crash landing. Today's seats can handle up to 16 Gs. Every inch of your economy seat has been precision engineered. Your tray table is tilted at exactly 3 degrees. Useless on the ground, but once the plane is angled in flight, this becomes perfectly flat. Once in the plane, the seat will spend up to 20 hours a day in use for over a dozen years. And so a brutal battery of tests has been designed to check that it's up to the job.
The passengers using the seats, they behaving completely different. So people just leaning on the armrest, maybe they're using it as a step somehow. This is like passengers pulling a bag out of the overhead bin and having it drop down to the armrest. This is the elbow. So during one flight, the armrest will seat 10 times to 115 newtons as an elbow load.
Unless you're an astronaut, an aircraft cabin is the most highly engineered environment you'll ever experience. Back at the terminal, passengers are boarding flight SA-261 to Johannesburg. The passenger flow team have steered them from check-in to gate. Their bags are screened and loaded, and the seats awaiting them are a marvel of modern design. It's seamless and total control from a mega airport.